So apparent motion will be familiar to you, at least it should be familiar to you, because it's the phenomenon that you see every time you look at a moving picture, at least in the days when moving pictures were shown as frames on film. It's all digital now, and that's a bit different, but it's also what you're familiar with when you look at television or any video. Again, a little bit different, but they both entail apparent motion. And apparent motion can be defined as the subjective generation of a sense of smooth motion from images that are sequentially static. And in a sense, motion is always about a sequence of images. And because time is broken up indefinitely into infinitely small units, and the nervous system can't deal with infinitely small units, there's always an issue of time and how the sequential images on the retina, or the continuously changing images on the retina, are put together into a smooth series. The starting point for thinking about apparent motion is to think of two flashes of light, indicated here by flash 1 and flash 2, and some interval of time between the two flashes of light. And it's easy to imagine, and you could think of ways of showing this without too much difficulty or complex apparatus, that if the two flashes are occurring at the same time, you see them as simultaneous. And if the two flashes are occurring at quite different times, let's say separated by a second, well, you see flash 1 and flash 2. So the range is from seeing them simultaneously to seeing them independently. But there is within that range intervals of a fraction of a second and less that will lead to your perception of motion from flash 1 to flash 2. You see this, I mean, if you walk down the street and see a parking sign to park your car and there's a series of light bulbs going on and off, you can see that the motion that's indicated to go into the parking lot is indicated by the sequence of bulbs going on. And if that sequence is fast enough, you'll see it as a moving direction to guide your car into the lot. In movies, frames are, or used to be, when they were shown on film, the rate of showing you these still frames was about 96 per second. And that's a bit of complicated technology because there are also blank, in that 96 frames per second, there are blanking frames so that the film can be moved and not give you a sense of blurring. But basically, this comes back to the sort of flicker fusion frequency that we talked about last time. And if the frequency between the frames of the moving picture are fast enough, and that has to be somewhere near the flicker fusion frequency, let's say 60 hertz, then you will see that as a smooth transition from image to image. You'll see motion of objects and figures in the scenes as moving smoothly. If they're less than, let's say, 30 or 25 frames per second, you start seeing jitter. So if you've seen old moving pictures where the technology was not up to moving the frames that fast, you'll notice that in Keystone Cop movies and Charlie Chaplin early movies, there's motion is not smooth, it's jittering, and that's because the frame rate was not quite fast enough. In television and video, it's a little bit different because the lines are being scanned continuously across the sensing screen, the television screen. But you will see, again, what are basically lines that are each one independently being generated as smooth motion if the frame rate, the equivalent of the frame rate of a moving picture, is fast enough. And the frame rate in television and video is of course plenty fast enough. So apparent motion is using images that are effectively still in real time, independent frames or independent dots in a video, and seeing that as smooth motion if the rate of change is fast enough. That's apparent motion. And it's not really a puzzle, but it's an aspect of motion that is technically obviously important for the domains of television video that are so important for us today.